Let's take a quick look at the heart. On your screen, you'd find an illustrated and well-labeled diagram of the heart and the basics that you need to know about the various divisions of the heart. Okay, you can see from this shape here, you can see that the heart is a conical shape. It has a conical shape, the shape of a cone. You can see on your screen here. So let's quickly talk about various physiology of the heart. The heart weighs about 300 grams. It's about the size of a clenched fist. Okay, at rest, the average human heart will pump, contracts and relaxes about 70 times per minute, and then it pumps about 14,000 liters of blood per day. But then you must know that during exercise or during strenuous activities, okay, the heart rate, the rate at which the contraction and the relaxation of the heart occurs can be higher. Okay, more than 70 times per minute. It can go higher to over 100. All right. Okay, so now we're looking at an illustration of the heart and different parts that are labeled. So I'm going to go ahead and explain to you the different parts that are labeled here and what they do. Okay, the different structures here. So we're going to start with this part here, these two, this one here and this one here, the inferior vena cava and the superior vena cava. What they do is that the superior vena cava takes blood from the upper part of the body and brings it to the heart. The inferior vena cava brings blood from the lower part of the body and brings it to the heart. They are both veins. Okay, note, they are veins, so they carry deoxygenated blood that has already delivered oxygen, to the body. So they return that blood to the heart. They carry deoxygenated blood, and you can see here, you can see the blood comes into the right atrium. Okay, this is from the superior vena cava, and this one here is from the inferior vena cava, and it comes into the right atrium. All right, so from the right atrium you would see valves here, these two valves here. Actually is shown to here, but actually three. Okay, the cups of this valve is actually three. That's why it's called tricuspid valve. Here, tricuspid valve. It has three flaps. Okay, now the tricuspid valve separates or guides the entrance that exists between the right atrium and the right ventricle. So it kind of regulates the blood that comes in from the right atrium to the right ventricle, and also it prevents blood from going back from the right ventricle back to the right atrium. So this is the tricuspid valve. So when blood comes from the inferior vena cava and the superior vena cava into the right atrium, the tricuspid valve will open and the blood goes into the right ventricle. Okay, blood goes into the right ventricle here. From the right ventricle will pump the blood up here, this direction here. Okay, pumps it into the pulmonary artery. There's the pulmonary artery, and the pulmonary artery has valves too, just the way the kind of valve you find here, the tricuspid valve. It has its own valves too. Here, these valves here labeled here, known as the pulmonary valve. Okay, the blood from the right ventricle is deoxygenated. Note, the pulmonary artery itself, this artery, okay, is one part of the body, is where you find it's carrying deoxygenated blood. It's not is the only variation in the body where you find the artery carrying deoxygenated blood. Okay, an artery here carrying a blood that doesn't contain oxygen. Normally the arteries transport blood that contains oxygen, but here we'll find the pulmonary artery carrying deoxygenated blood from the right ventricle. Okay, see, you can see the pulmonary artery here will divide into two at this junction here, just below the aorta. It divides into two, and this one here divides into two. Okay, now this is the left. This is the left and the right. Okay, pulmonary arteries. This one goes to the one of them. This one here goes to the right lung. This one to the right lungs, and this one will go to the left lung. Okay, so when the blood gets to the lung, what happens is that it delivers carbon dioxide there. There is gaseous exchange. delivers carbon dioxide, and then it collects oxygen. Okay, collects oxygen. Then from the lungs, the pulmonary vein here takes blood from the lungs. Let's say the lungs, this is the right lung here, and then there's another lung here. Okay, the left lung here, the left lung here, the right lung here. So what happens is, here at the lungs, okay, the pulmonary vein will take the blood. Now you see the pulmonary vein is taking blood from the lungs, and the blood is taking, even though it's a vein, it's taking blood that is oxygenated. Okay, this is another variation where you find the vein in the human body. This is the only place you find the vein carrying oxygenated blood. Okay, it's carrying blood that has been oxygenated from the lungs and then brings it back to the heart. Okay, and then delivers it into this, the left atrium, this chamber here, the left atrium. It empties into the left atrium. The same thing happens here too, from the right pulmonary veins, taking blood from the right lungs, they bring it straight here too. They all empty into this place, the left atrium. Okay, the left atrium is guided by these valves here, this valve, this valve, this valve, known as the mitral valve, or also called the bicuspid. It's called bicuspid because it's two. The flaps are two. Unlike the tricuspid where the flaps are three, in the bicuspid the flaps are two. So it brings blood into the left atrium, and then this bicuspid valve allows the blood to get into the left ventricle. Okay, the blood gets into the left ventricle. The left ventricle is highly muscular. All right, the left ventricle is highly muscular, and so because it's highly muscular, because it does much work than all the other chambers. Okay, its function is to pump blood from the heart to the other parts of the body. Now you can imagine, so the rest are kind of receiving blood, and then the right ventricle just pumps blood to the lungs, but this left ventricle pumps blood to all the parts of the body. Okay, so it's very muscular, is very strong. So what it does, it pumps blood here. Here also we have a valve, okay, guiding the aorta. So the left ventricle pumps blood into the aorta, okay, from the left ventricle to the aorta. Now there are valves guiding there. These valves are known as the aortic valves. Okay, the blood goes in from the left ventricle, goes into the aorta this way, and then from the aorta it goes out to the blood, to the body, the rest of the body. You can see it goes out to the rest of the body. All right, that's the basic pathway that blood follows within the heart. Okay, that's the basic way that the heart pumps blood from itself to other parts of the body, and also how it receives blood from other parts of the body to the heart, and then sends it to the lungs to get oxygenated. Okay, and then from the lungs through the left ventricle takes it to the aorta, and then from the aorta it delivers it to the rest of the body. You must know that the blood that is entering the aorta from this left ventricle is at high pressure. Okay, it's at high pressure. It can be up to between 105 millimeter mercury up to 110, even sometimes greater than that, depends on the individual, but it's roughly about 105 millimeter mercury. Okay, because of course it needs that amount of pressure to be able to get to other parts of the body, because that's a long distance from the heart to every part of the body, is a long distance. Okay, now the blood that is entering the pulmonary artery is at a much lower pressure. That's from the lungs. Okay, no, from the right ventricle. The blood that is entering the pulmonary artery to the lungs is at a much lower pressure, because it doesn't require that high pressure. All right, just the distance from the heart to the lungs is very little. It's not that much. It's not, you can't compare to the distance from the heart to the rest of the body. From the right ventricle to the other parts of the body, the pressure is very low. It's about, let's say, 60. It's about 16. Okay, 16 millimeter mercury. Okay, yeah. So basically this is the basic function, or the basic um, pattern about how blood moves within the heart. Okay, and how the heart receives blood and how the heart sends blood to other parts of the body.